So in the last video, on the last topic, we talked about how we found the global force at each node, and we found the displacement at each node. So using this, we can determine stress within the element and the strain in the element. All right. So before we can calculate the stress and the strain, we need to know our nodal forces. Okay. So our nodal force for element 1. All right, so if we have our element 1 here, all right, it had so it has two forces. It has Fx1 at node 1, and at node 2 it has Fx2. All right, so this is element 1. All right, and we know that Fx1 and Fx2 are related to the known displacements U1 and U2, and the known k constants k1 and or the known uh, stiffness matrix, which is defined here for the first element. So all we're going to do is we just plug in our values for u into this equation, and then we can calculate our nodal forces at point 1 and at point 2. All right. So so to calculate the stress, what we can do is we can use the following equation where the stress within the element is going to be equal to the elastic modulus of that element divided by the length of the element times the second uh, displacement minus the first displacement. All right, um, so what we end up getting is we're just going to plug in the values for U1 and U2. So U1 is equal to 0 because it was fixed, and U2 was equal to F3 over K1. So if we multiply all this out, what we end up getting is we get sigma x1 is going to be equal to E1 over L1 times -1 times 0 plus F3 divided by K1. Okay. Now, what we end up getting is we get E1 over L1 times F3 over K1. Now remember, K1 is equal to A1 E1 over L1. So this actually simplifies down to just being equal to force 3 over A1. Right, which makes total sense. The force applied on both sides of the element is causing the element to act in tension here. Right, and then we know that for an axial stress, that stress should just be equal to force over area. Okay, so in this case, our force over our area would just be F3 over A1 for element 1. Right, so in a similar fashion, we can just use Hooke's law to determine, for a uniaxial case, to determine the stress within the element. So we can say that we know that Hooke's law says that the strain is just equal to the stress divided by the elastic modulus. So if we did that, the rest of the equation would just be the same, except it would just be divided by the elastic modulus, and the answer that we would get would just be the same thing, just with the additional elastic modulus term. Okay, so that is all you. So in short, once you have the global force matrix and the global displacements, you can calculate the nodal forces, and then but in addition to that, using the displacements, you can calculate the stress and the strain within each element using the stress and strain equations that we've defined here.